Dr. Sivarasu. Dr. Sivarasu has done his PhD in renewable energy from Anna University in 2015. He is a lead auditor ISO 14001-2015 on environmental management system, certified professional of green rating of integrated habitat assessment, CII certified professional on sustainable waste management system, implementer and auditor for carbon footprint management, ISO 14064, in industrial consultancy projects created for railway colonies. Currently, he is working as a managing partner at Mrs. Ram Kalam Center for Energy Consultancy and Training. And he also has a membership in professional bodies like Institute of Engineers of India, that is IEI, Quality Circle Forum of India, QCFI. Sir, we are very much eager to listen to you. Over to you.
Many thanks to the JanyuTech Technologies for inviting me for the Saturday talk series. And I saw the previous legends who gave the presentation in the same Saturday talk series and their topic also. I was wondering why they called me and gave a topic of improving energy efficiency and all those things. But it is quite natural. Not even a single person can be a warrior for saving the energy, conserving the energy. So in this forum, we are normally going to discuss about a very small concept of energy conservation and energy efficiency. But it can be applicable to any type of industry. Though your industry is not using much amount of energy, much amount of electricity, much amount of LPG or whatever may be, but you can suggest or you can carry out this type of activity in your other industries and similarly for your friends' industries. So today's topic is, before going to talk about the technical points, I would like to thank the management of JanyuTech Technologies, especially to my ex-colleague Senthil Vinayagam sir for inviting me and gave this opportunity. The presentation overview is very simple. Totally, we have only 45 slides, out of which only 40 slides are informative. I don't know whether it is informative or not. At the end of the presentation, you respective people who have to tell whether it is informative or not. Similarly, the presentation starts with what is energy efficiency and why it is necessary. Major energy systems available are used in industries. Energy efficiency through energy auditing and energy management systems, and what is the outcome and need for energy auditing. And with the example of some simple case studies, we have around 160 energy audits carried out around all over South India. We have simple case studies, we have bombastic case studies also. But I know the people who are from different background, so therefore the presentation should be very simple and should be understandable in the point of energy conservation and energy audit. And finally, we are going to touch about the low cost and cost investment based energy conservation proposals and the way of getting the energy. A slide will give you a clear-cut idea which is available in the net itself. Anyone want to buy one particular brand of 1.5 ton AC, inverter AC, particularly inverter AC, with a 3-star rating and 5-star rating. You can just compare the column number 1 and column number 3, where 3-star rating costs around some amount and similarly 5-star rating costs slightly higher. Approximately 4,500 rupees is higher than compared to the 3-star rating. People will always think about the investment cost, initial cost or capex, but nobody will talk about the opex. Even the manufacturers, OEM also will not give the operating cost and their savings. Normally, the energy efficiency was long period it was ignored. Let us say in a cricket match, one can able to talk how much amount of run scored by a batsman. Similarly, how much amount of wicket taken by a bowler. But no one can talk about the run saved by a fielder. Energy efficiency is like. So if you save or if you invest 4,500 rupees extra than compared to the 3-star race, you can get the total amount of money within 6 months. Remaining money is going to be completely saving for you. So keep remember, the Bureau of Energy Efficiency is the only sole authority for India for the Energy Conservation Act or whatever may be the system. They will always tell that any proposal, any conservation activity, any energy efficiency activity should have a payback of less than 2 or 2.5 years or maximum 3 years. So if it is maximum 3 years, it is attractive. If it is more than 3 years, it is not attractive, but it should be decided by the management. Okay. Now, my intention as faculty, as an auditor, as a conservative people, my intention in this seminar is to focus from the preliminary point of view. And this diagram is a single line diagram. SLDV is single line diagram of an electrical system where one can start from generation point to the load point. Any people from the background of electrical engineering will know this diagram. And moreover, you know that the generation point is here and here. And we know that the generation point is very far away from our ability. So I just mentioned the efficiency values in the top. 80% is the efficiency of a generator. Transformer efficiency is 99%. Transmission system 80%. I'm lavishly filling this data. The practical values are completely lesser than this value. You know that the efficiency of the current generation plant is going to be around 60 to 70%. Again, this depends on what type of plant it's going to be. And similarly, the transmission line efficiency is going to be 60 to 70%. But I'm lavishly putting this value. So if I want to know the cascaded efficiency or end-to-end efficiency or one-to-one efficiency, then I multiply 0.8 into 0.9 into all the values, then cumulate, which is exactly equal to 44%. Remember that I am not including the turbine. So if I include the turbine, then automatically the efficiency will again still come down because the turbine efficiency is only 30 to 35%. So if I include the turbine, then automatically the value is going to be around 30%. That means if I generate 3 unit here, I will get 1 unit. That is the scenario available all over the India. Maybe by different states will have a transmission distribution losses different value. You just click on to the Uday website, go to the particular state, and you can see, and you can wonder what is your transmission distribution system for your state. Okay, but generally speaking, the one third is going to be the available energy for the user point of view. But as an energy auditor, as an energy conservator, I want to tell the people, don't think that if you generate 2 units of electricity here, 1 unit is going to be you will get. But rather, if you save 1 unit of electricity at your end, that is exactly equal to saving 2 units of electricity at the generation end. That's the point I want to always tell, and this is the point always our President Abdul Kalam also tell. Now, this is the major energy consuming equipment in industry. The left side is going to be completely electrical. The right side is going to be a combination of electrical as well as mechanical system. I am not telling that all the systems should be available in the factory or in the industry, but most of the systems is going to be commonly available, right? Now, the building system for electricity. Now, electricity consumers, whatever maybe, is going to be a commercial building or an industry or an educational institution. There are only two type of consumers. One is an LT consumer, another one is an HT consumer. Of course, the demand, the transformer details, the sanctioned demand, tariff structures, KVA demand, the demand charge, everything is going to be completely different from one state to another state. And you know that you are sitting in the Mumbai office, and Mumbai is going to be completely connected with Maharashtra. Maharashtra is now going went for an KVA billing. They are not following the KWH billing as in Tamil Nadu. In Telangana, Andhra also went for KWH billing. Pondicherry also went for KVA billing. So the different type of states are following different type of the methodology to calculate the energy, calculate the losses. Similarly, for the billing system is also different. But the idea is whatever may be, whether it's going to be LT consumer or HT consumer, the jurisdiction for the LT consumer and HT consumer is also different. But the billing system is going to be different. Even though billing system is going to be not unique, but it is our right. It is our responsibility to save energy, right? Now, energy conservation, energy efficiency are not same. Remember, both are different, but commonly used, intermittently used. Energy efficiency is same. You want to do the same work, but the sophistication or the comfortness you should not lose. So that's called energy efficiency. But energy conservation is different. In case if you have a system, that system should be running for 24 hours, and you can identify where is the ideal time. Is there any ideal time is available? Then on that time, you must turn off the system, or you can reduce the operation of the system. That's called as energy conservation. So most of the cases, the energy conservation and energy efficiency go hand in hand, but it may be interpreted differently. Now, energy efficiency or energy conservation normally can be obtained or can be fine-tuned or can be taught to the industry or the core industry or core people with the help of an energy auditing. Whenever if you conduct an energy auditing, then only we can able to find where is the gap. Is there any gap available? How much gap is there? Is there any possibility to fill the gap? And similarly, what are the ways to fill the gap? So energy auditing is going to be a very important or integral part of any industry, any commercial building, any education. It must be an integral part. You know, each and every education institution should go energy audit as per the NAC 7.1.6. So the idea of energy auditing is to identify the leakage. First important point is to identify the leakage. Sometimes the leakage will be visible, sometimes the leakage will be invisible. So invisible loss, invisible leakages should be identified with the help of the meters. And similarly, some of the industries are paying higher cost towards their energy bill. They don't know how much is the energy bill. Even your utility bill cannot be able to visualize, cannot be able to understand, because the bill contains so many informations. So sometimes it may be the people will confuse what is the exact value I paid, what is the exact consumption I use, and those things. And some of the industries are asking us to conduct the energy auditing to know the present status of the consumption. And the last 2 point is market competition. What is the importance of energy auditing is to reduce the energy consumption, present energy consumption, without affecting the productivity. So therefore, they can go for an energy auditing. Market competition is going to be one of the biggest factor, as you know that. Earlier case, only we developed the component or we developed the system. Then later on, the nearest city developed, nearest state developed the same component. Now the nearest country developed the same component with the higher quality, less price. So it is a global scenario. Similarly, for input cost is going to be keep on increasing. Raw material cost is keep on increasing. Manpower increasing, transport increasing. Everything every year on year, you have to increase the manpower costs or raw material costs. Now, outcome of any energy auditing activity or energy conservation activity, I can tell you with a simple example. I have a system, and system is running for only 1 hour. Let us assume that I have a system which is running for 1 hour. For 1 hour, it takes 100 unit of electricity, and it produces 100 pieces of energy. Right? Then one hour. Running time, 100 unit is the intake, 100 piece is the output. So automatically we can come to a conclusion that for 1 piece, 1 kilowatt of one unit of electricity or 1 kilowatt of electricity is used. Now, if I do some energy conservation activity, same 1 hour, same system running for same 1 hour, takes same 100 kilowatt hour. Now it is producing 110 pieces out. Then automatically your specific energy consumption for producing same 1 unit or one piece output, your energy consumption is reduced. This is one point. Whereas same system running for 1 hour, right, producing same 100 pieces but taking 90 kilowatt hour, 90 units of electricity. So this is also comes in the case of energy conservation. So most of the energy auditors, most of the energy conservation people or external consultant will focus on same energy with increased productivity or same production with reduced energy. This is the normally most of the 99% of conservative energy auditors, conservative energy consultant will do. But what we are focusing is same 1 hour running 90 kilowatt hour, 90 units, 110 pieces. This is what we are doing. That means increase in productivity with reduced energy is the Taraka Mantra of Bureau of Energy Efficiency. So this is a definition for the definition pronounced by the Bureau of Energy Efficiency. Energy auditing is monitoring, verification, analysis of use of energy, including submission of a technical report containing a recommendation for improvement of the energy efficiency with a cost-benefit analysis and an action plan to reduce energy. Out of the definition, I marked some of the words in different color: monitoring, verification, analysis, technical report, recommendation, cost benefit, and what is this? How I can monitor? Whether I monitor visually or do I need any meters to conduct the experiment, taking the reading? Do I need any external consultant required to monitor? Yes. You must sometimes you may monitor visually, sometimes you need to take some readings, and that reading should be verified. Where I have to verify? Is there any standards are available? Yes, you have a standards. You have a test result. You have a nameplate details. So that you have to verify. With that you have to verify. And similarly analyze if there is any gap, if there is any deviation as per the standard, as per the technical report, as per the commissioning report. Then you have to clearly analyze why this gap available, why this system is running this. Then based on that you have to do a technical report. That technical report should contain recommendation. What type of recommendation? It should have mainly focusing about the cost benefit. How much amount of investment I have to make? How much amount of what is the payback period for each and every investment? Let us formally speaking, any auditor should focus on no cost investment. Without investment, is there any possibility for reducing the energy? That is the first important focus of any energy consultancy firm. And similarly, second case is going to be low cost investment. Then third is going to be cost investment. We know we can change the normal fan into BLDC fan. The energy saved. We can change the normal AC into an BLDC AC. There's a possibility for saving. We can change the old motor into IE2 motor, IE3 motor. Yes, we know. We know that. Even Sivarasu does not need to tell this. Everyone will know by changing the old system with the new system with the higher efficiency, energy saving. But how much amount of cost I have to invest? What is the payback period? What is my operating system? Whether it is going to be running for 24 hours or 12 hours or 8 hours. So based on that, I have to calculate, I have to project this information to the management, and this saving should be less than 3 years or less than 2 years is going to be attractive. And also you have to tell what is the action plan to do this. Who is the vendor? Who is the contractor? How to do this? And how after implementing this, how to monitoring this, how to monitor your savings, how to monitoring your intangible and tangible benefits. That also you have to tell. Now this is the simple executive summary which is given to any of the energy auditing certificate, which is mainly for the management. Where what is your present consumption? What is the possibility for the savings? And after the saving, how much you can able to pay it? And similarly, how much amount of CO2 reduction in after saving, and how much amount of initial investment required to achieve the saving, and similarly what is the total overall payback period and what is the total overall reduction of energy. And this is the sample report, sample format for proposal, just representing 9 proposals, low cost proposals, medium cost proposal and high cost proposals. Each proposal, how much amount of energy can be saved, what is the energy saving, and how much is the monetary benefit, and how much is the investment, and each investment against what is the simple payback period for each proposals. Right now, we just come to our technical point. Most of the industries are looking for low-hanging fruit, as you know that without investment, zero-cost investment, slight change in the process, slight change in the behavior of the system, slight change in the behavior of the people who are working in the system, slight change in the behavior of even management also will give a good and fruitful result. So that can be an zero cost. Let me give some examples of low cost and cost investment based proposals as per the case study, right? This is the recent case study we done for in Chennai, where they are manufacturing the pressure cooker gaskets, right? They have a 15-ton chiller, 5 into 3-ton chiller, which is normally running for morning 9 o'clock to evening 7 o'clock, right? Intermittently, they have 2 breaks. One is a morning breakfast, and similarly afternoon is going to be lunch. The inlet water pressure, the inlet water temperature is going to be 21 to 22 degree. Normally, the outlet temperature from the machine is going to be 26 to 27. But my intention is half an hour is going to be a completely break for both morning tiffin as well as afternoon lunch. So 1 hour the chiller is keep on running. They do not know that they do not switch off the chiller. But what we are suggesting is you put a simple timer. Whenever the machine is off, automatically your chiller is also off. Whenever the machine is start, automatically chiller is going to be start. Or you can set a timer before starting the machine. Either you can start the chiller previously 2-3 minutes before that. That is enough, because your operating temperature is around 21 to 20 degrees. So the chiller can be able to capable of chilling the water very quickly, rapidly. Then automatically you can save 30 minutes of operation, and yearly it's going to be 160 hours of operation. That can save amount of energy 2,700 unit. If you convert that into a cost, it's going to be around 24,000 rupees. Almost a zero cost. Just you can have an electronic controller. Within 3 days they implemented this. They got a good result. And what we proposed is the 30 minutes, but they achieved 45 minutes is the cutoff period for both the breaking time, and they can achieve more than 3,500 units expected unit is up. But what is the problem? What we study is, we know that Coimbatore area is abundant of solar, and normally the sunshine hour is going to be 4 hours. I'm just taking a very, very minimum value. You know, this Coimbatore is will hot now, and it is going to be around 4 to 4, more than 4.5, even 5.2 also we got it. But I am taking the sunshine hour of 4 hours per day into 250 kilowatt into 320 days. The total value amount of expected generation is 3,20,000. That means this system can able to capable of generating 3,20,000 rupees. Even though if you put 300 days, it's going to be 3 lakh rupees, 3 lakh kilowatt hour. But they are generating only 2,50,000. 50,000, 70,000 is the short take. What is the reason for that one? When we inspect, out of 5 inverters, any one of the inverters under fault condition. We don't know what is the fault. But even the fault is available, fault occurs. The people in the maintenance does not know. Or immediately they are not knowing. Immediately they are not attending the fault. So automatically the fault is prolonged for 3 days, 4 days. So when we inspected, we found that any of the inverters are keep on fault. So therefore, we recommended that you keep one inverter as a standby, and you can find out. You can link all the inverters with the help of a meter. And if any meters goes wrong, if any meters is not working, immediately the alarms will come. So automatically, the person who is in charge for that one go to that, check it whether it is going to be rectified or not. If it is not rectified, replace with an existing standby. Then you can put the machine, put the system back to generation. So automatically you can save 70,000 rupees, 70,000 kilowatt hour. If you convert that into a unit, it's going to be around 5.5 lakh is the cost without investment. Now, second important point in this case, it can able to generate 3,20,000 unit, but they are generating only 2,50,000 rupees. But the load is there. You can see the load pattern. They are having load. So the load is there. the solar photovoltaic is also having a generation capability, but they are not generating. So the gap is 70,000. 70,000 unit is the gap, or even 50,000 is the gap. Suppose if the solar is not generating, then automatically this 70,000 or 50,000 can be brought from the EV itself. Am I correct? So not only it's a single loss, it's a double loss. So 70,000 you are not generating, so therefore you are losing 5.4 lakhs. And similarly, if you are so for the same 70,000, you are buying same from the electricity, so therefore you are again paying the same amount. So it is almost double, almost 11 to 11.5 lakhs is the loss for the company. So this is the simple and no cost investment. Let me come to the point of the low cost investment. With a small investment, a big change can be happening. So for that, I'm taking two examples in the motor. As we know that motor is going to be a very common, very funny thing, and everyone will know about the motor working principle and all this, right? Power transmission from the motor to machine. Motor is mainly used for producing the mechanical power, because it takes electrical power and it transmits the mechanical power to the machine where it is connected. The connection between the motor and the machine is mainly basically between chain or belt and pulley. Even we have a flat belt and V belt, or direct coupling with variable frequency drive or variable speed drive. So these are the four possibilities normally used in any industries, right? Then we come to the point of the small cost investment based energy conservation. Again, I am taking the motor. Because this is very simple example. Let us assume that I have a 3-phase 4-pole 18.5 kilowatt 24 HP, 25 HP 1460 RPM motor, which is put into service exactly 10 years back. It's not exactly the exact data. Exact data is 15 years back. For the sake of simplicity, I am putting the date 25/2013, 10 years exactly back. Now, the fault history of the motor says that motor management plant in the industry says that 5 times it is coil rewinded, 1 time front bearing failure, right? What is the present issue in the motor is excess heat. Running noise is going to be enormous and vibration is also higher. Now you are asked to replace the old motor with a new motor, and you found out that old motor will not have any nameplate. Nameplate is available, but efficiency, whether it is going to be an IE1 or previous EFF1 or EF2 class. But you are decided to go for an IE3 motor. As you know that as per the government of India, as per the BS standard, any new motor can be replaced with an IE2 motor, at least IE2 motor. IE3, IE4, it depends on the management of the industry. So IE3 motor, same efficiency, same capacity motor, have an efficiency of 92.6%. Right? Now you put a table. Existing motor is 18.5 kilowatt, 85% efficiency. You are requested to reduce the drop by 1%, efficiency drop by 1%, because we know that whenever if one time coil rewinding, 2 to 3% is the loss. But we are taking only 1%. So 5 time rewinded, so 5% loss. So 18.5 divided by 0.8, 80% is 0.8. So it will take 23.13 at full load condition. Whereas the same new motor, 18.5 kilowatt divided by 92.6 and 0.926 will take only 20 kilowatt. So if you replace the old motor with a new motor, the saving is going to be 3.13 kilowatt. The running hour per annum is going to be 6,000. So approximately 3.13 into hours will save nearly 19,000 kilowatt hour, 19,000 unit. If the cost of the electricity on that particular area is going to be 7 rupees per kilowatt hour, then your cost savings is 1.3 lakh. Automatically, your eyes will open. Eyes will be glorious. Your face will be bright, and you can tell your management that, sir, if you invest same brand or even better brand, including all transportation costs, installation costs, GST or whatever may be, the cost of the motor is around 70 to 80,000 rupees. But lavishly, we are putting 1 lakh rupees. If you invest 1 lakh rupees, you will get 1.31 lakh rupees in a year, or your payback period will be only 9 months. So automatically, what you are going to do is, you are taking the similar type of motor in your industry and identify 10 motors are available in the industry, and you propose the same scheme to the management. Rather than one replacement of one motor, if you go for 10 motor replacement, then automatically you can save huge amount of energy. But apart from that, you are telling that there is a plan available by EESL. EESL is an Energy Efficiency Service Limited. It's a government company, central government company, where there is a program called the National Motor Replacement Program. This program is mainly used for replacing your old motor, rewinded motor running more than 10 to 15 years, very, very old motors that can be replaced with an innovative model of IE3 motor, and they can assure a financial takeover of 35%. Out of 1 lakh, they will buy the motor at a reduced cost from the direct OEM and they will give it to you at 35% reduction cost. So your cost of the motor earlier is 1 lakh, now it is come to 65,000 rupees, and they can take a small amount of margin. So apart from that, you will get 35% discount for each and every motor. So this is a very attractive plan, but it is not meant for only one motor or 10 motor. It's when you have a group of motors more than 100 or more than 50, more than 100, more than 200, it will be very attractive, and you can approach the ESL for implementing this activity. Right. Apart from that, automatically, if you check your EB bill or energy bill or electricity bill, whatever may be, that will give a lot of information to you. Let me check only two electricity bill. One is LT bill, another one is HT bill. I'm telling this is only meant for Tamil Nadu electricity board, not for your electricity board. You can check the same way what we are talking now for your electricity bill, and similarly for your residential application, your commercial application, or your industry also, right? Now, this industry is an LT industry having a connected load of 54 kilowatt. For every less than 54 kilowatt in Tamil Nadu, 2 months only the reading was taken. So 54 kilowatt, the recorded demand, what the maximum met is going to be, maximum is going to be 14%, right? Maximum is 14 kilowatt, maximum is going to be 26%. But this company has to maintain a minimum power factor of 0.85. But at any month, they are not maintaining the power factor of 0.85. So the average power factor is 0.75. So because of that one, a penalty was put in for the company. That's called disincentive power factor, which comes around 31,000 rupees. The overall amount of energy they are consuming is much, and overall amount of energy paid is going to be this much. So out of 3 lakh rupees or 3.2 lakh rupees in a year, the 31,000 is going to be a penalty. So around 10% is the penalty. So if you check your bill, we can easily identify whether your energy consumption is very judicious against your bill is very judicious against your energy. That can be easily find out. This is the second bill, which is meant for HT application, where again the same thing is going to be applicable. Here, your disincentive power factor bill, disincentive power factor. Similarly, excess demand also there. Their total capacity is 250 kVA. So sanction demand is 250 kVA. So they exceed the demand in some of the cases. See, 100%, 105%, 116%. They put a penalty for exceeding the limit. So therefore, the penalty comes around 76,000, and this comes around 8,000 rupees. Put together, it's going to be around 85,000 rupees. Is the annual penalty paid by the company. So as of now, only penalties are available. No incentives are available. I hope this can be applicable all over the India, right? Now, this is another interesting case study, which is completely applicable to the operating profit margin. I told you, because of lesser margin for the industries, because of higher competition from other countries, other manufacturing plant, the operating profit margin is going to be completely reduced. That's why we are introducing the specific energy consumption, SEC, for any product. Now, this is meant for an tea industry, which was conducted earlier, and the amount of tea produced in mud tea is here, and they are using firewood for firing the tea, drying the tea. So this is the cost of the firewood. They are using electricity. The electricity cost is here. They are using diesel, standby fuel, and the cost and the total cost is here. But what I'm going to do is, the total cost is 16.85 lakhs or 17 lakh rupees. The amount of mud tea is produced here. Then I'm calculating how much amount of cost for 1 kg of tea. So for 1 kg of tea for the month of October 2018, it's going to be 13.37 rupees. Approximately 13.55 rupees. Now this should be same as we discussed the very earlier. For 1 hour running, 100 pieces, 100 unit. If it is 50 unit, 50 pieces will become. But here you can see for the entire year, 13.37, 13.58, and it is go 14. It goes again drop down to 12, again increase it to 25, again go to a maximum of 42. It is not unique. The problem is different. So this type of industry should be given more focus. Why this variation happens? As we know that it is a tea industry. Tea will be grown in the hilly areas. In hilly areas, you know that the wood consumption is very higher in the winter season. So similarly, in the winter season, the wood consumption is also higher. The cost of the wood is also higher. So that will increase the firewood consumption part. Firewood cost is increased. Second thing, on the lean period of January, February, and even December, January, February is the lean period for the industry. Even though the industry is lean period, but but your fixed cost of the electricity will be the same. And similarly, quality of the withering, quality of the leaf, so many parameters we analyzed. We got around 40 important parameters, out of which 40 factors affecting parameters. Out of 40, we got 8 factors affecting parameters, and that can be focused in a very bigger way to reduce the specific energy consumption for making the tea. And we are trying to reduce this amount by at least 1 rupee per kg. That would be a huge saving for any industries. Apart from the energy conservation, we know that the conditioning monitoring or best operating practices is the very important tool for any industry. Suppose if you have a machine, whether it's going to motor, generator, boiler, furnace, transformer, whatever may be, a capacitor plant, whatever may be the machine, it should be properly maintained as per the plan, as per the OEM plan, as per the maintenance plan, as per the highest standard plans. So for maintaining this one, we know that we have so many methods available: fault-based maintenance, preventive maintenance, predictive maintenance, proactive maintenance, so many parameters. So each and every area, each and every maintenance plan, we have certain tools are available to identify whether the machine is working without problem, or is there any chance for creating the problem that can be easily identified with the condition monitoring tool, right? One of the important tool is your thermography. As we know that without seeing this, with normal eyes, we can't be able to see the thermal image, the hotspot of the system. But whereas the thermal imager, thermal guns and thermal images will give you a clear-cut idea. This is some of the screenshot we taken on the motor driving it is connected with the machine, so therefore it's called as a driving it. Non-driving it is the opposite side. There is a small gap, there is a small difference between the driving in temperature and non-driving in temperature. If the driving in temperature and non-driving in temperature more than 20 to 30 degree, then automatically the motor is going to be not able to capable of dissipating the heat via the outside, so therefore the motor start boiling. See on the pulley side, on the contact side, on the back side of the machine, other machines, and similarly for contactors, body of the motor, so many things. Best operating practices, it should be for electrical system. Observe the load condition, running efficiency should be available. You have to check the load current and no load current before and after the rewinding. Earth leakage current you have to check. Thermal heat on the body, audible noise, bearing conditions, tension of the belt pulley slippage. Every maintenance plan should have a service card for every motor, every machines. And similarly, if the motor is a new motor, you can put a red color on the motor. If it is a one-time rewind motor, you can put a yellow color. If it's a two-time rewind motor, you can put a red color. Red color indicates that it's a two-time rewind motor. After that, you can't able to do the rewinding. Fault history should be very pakka. Special attention should be given to the faulty motor or rewinded motor, so that will reduce your lean stock. I think you will be very happy after this slide, because this is the last slide. So in this presentation, I'm just touching a very simple concept about the maintenance of the system, and which will lead to a failure of the system, and that will also lead to energy conservation. And we saw the basic about the energy conservation and with this simple case studies. I think I completed it within the time. Now I'm ready to answer your queries.
You have told that the IE3, IE4 standards of motors are there, right? Okay, and can you briefly tell what is that exactly?
Sir, IE3 international efficiency motors, sir. These motors will have a higher efficiency because the design changes are tremendous, and moreover they are using almost clean copper wire. So earlier case we have an EFF1, EFF2 motors where the maximum efficiency is 89% only. Now introduction of IE2 motor have a higher efficiency. Now Government of India insisting that any new motor, any new machine will be implemented with IE2 motor. This is the rule, but no one will follow it. IE2 motor will have a lesser efficiency. IE3 slightly higher efficiency. IE4 is there. IE4 even better. If you want to implement IE4 motor, then the efficiency is going to be around 96.2%. The same 18.5 kilowatt 25 HP motor, 96%. But only thing is, cost of the motor is going to be slightly higher. And I want to tell you one important thing. Motor cost, entire life cycle cost, if you take it is running for 20 hours, say 20 years, the total amount of EB bill or the cost incurred for the motor. Similarly, running costs. If you put all the value for the entire life cycle of 20 years, then the initial cost, investment cost is going to be only 5%. Only 5%. That is why we are insisting to the people, if you have a chance, you have an older machines, if you have a multiple time rewinded motor, then it is a time to replace with at least IE2 motor or IE3 motor. It is international efficiency 2. Category 2.
Okay, we see in the compressors 3-star and 5-star. The 5-star
Yes.
is the highest rating? Or?
Definitely, sir. Definitely. BE is the only sole authority to provide the star rating system. As more star will more savings. Simple strategy. More star, more saving. 1 star, lesser saving, lower amount, lower initial cost. 5 star, higher amount of saving, slightly higher.